Thank you, Billy, and thank you to everyone who's still here today. So it's been a great day for me, the first time at the water conference, and really what an exciting moment for us. It was 2 years ago for some of the people on our Meadows Foundation team came to Alpine for the inaugural Water West Texas Conference. And it was at that moment, some conversations that we started learning about some of the needs and felt that there was a real opportunity to make a difference. We had already seen the opportunities that had been created in 2012 when we established a Water Institute at Texas State University, and this was then a follow-on to that opportunity. But if you don't mind, I'd like to just for a couple of minutes just kind of tell you how the Meadows Foundation really got here. It really started my great uncle, who started an oil and gas company. This is a story that repeated many times in the state of Texas. He was a Georgia boy. He migrated to Texas, founded his company, and started building a fortune. Became very successful. And this was started in the early 30s. And about 1948, he had the idea as a very successful businessman at that point that he should do and start giving back. So we established the Meadows Foundation at that point. We didn't really have a lot of information over the years about what it was that got him started in philanthropy, at least. He made, in those days, typically made grants to hospitals, to schools, and museums, basically. That was kind of what was done. And it was really many years later when some of the folks in my generation, we are called the third generation, who got together and said, we think we should really start doing some things with the environment. Let's concentrate a bit more of our efforts on the environment. And through that moment, and from that moment, we started primarily in those days, early days, making habitat preservation and conservation grants. We worked with the state, particularly Texas Parks and Wildlife, developed a very close relationship with Andy Sampson at that point. And a few years later, in 2012, we had an opportunity through some conversations again with Andy to make a big investment in water. The first time really that the Meadows Foundation had really established an interest, an exceptional interest in water, but we were learning about it up to that point and felt that the opportunity was right, the leadership was right, with Andy Sampson leading the way as the first director of the Meadows Center for Water and the Environment at Texas State University. So it was really at that point that we as a foundation began to learn about water. But then it skipped forward to 2 years ago. So we stayed engaged with water and have since 2012. This conference, 2 years, I guess it was 2024, the first conference, we showed up, had these conversations, and really that was the moment of birth for this. And it seemed to be really full circle for us in that, Al Meadows had made his fortune in the state of Texas. He felt so strongly about that his fortune should be recycled back into the state of Texas. And so that's where we are today, thinking about things that are under the ground in the state of Texas, in areas that are not too far from oil and gas production, and in places where people are thinking about things that are going to affect future generations, as Al Meadows, I think, did himself. So on behalf of the Meadows Foundation, I would like to say this is a great honor for us, but I'd be remiss if I didn't mention some of the people, specifically the people who got us to this point. So to begin with, this kind of the leadership that you have at this university, Sullivan State University, has been evident from the beginning. So that's starting at the top with President Hernandez, Provost Cantez. I mean, without their involvement from the very beginning, it just doesn't happen. So it's this, bringing these coalitions together. you don't have that kind of leadership in your university or your institutions, it's just really not going to happen that you're going to be able to attract philanthropy and dollars to it. So being organized and having support is really important. And we're a Dallas-based foundation, so it's not like we're right around the corner from you guys. So it is important to see that. But it's also important that the people who are kind of boots on the ground are making it happen. And Lewis Harmiston was the man that stepped up immediately and started forming this kind of group to start looking at it. The steering committee, which he brought together, was led by Sarah Schlesinger and also by Vanessa Williams. We're really the A-team that started getting this conceptualized and brought together. So now you see there's an amazing brand here that we hope you'll all be thinking about and getting stickers or whatever you can find with that brand on it. Get the word out, let people know about West Texas. There have been a few other people, of course, interim director Billy Tarrant, who introduced me. He has been amazing, as well as Kevin Branson, who's the research science behind so much of this. So all of that's way over my head. I can tell you I have just been taking notes and trying to understand everything that goes on in this room, from the science to the law to the landowners and just so much. It's been a real pleasure to be here. You've got something really good going on. And I feel like Texas water, and specifically West Texas water, is going to be able to really unify, I hope, through and around the Meadows Research Institute for West Texas Water. Thank you very much for having me.
Thank you so much, Eric. So appreciated. Once again, I'm going to read. How's Sonora State University? This next session, we're going to try to show you, give you a glimpse of some of the work we're doing already and what we can be doing in the future with the team we have in place now and the team building. How's Sonora State University Meadows Research Institute for West Texas Water advances collaborative water solutions in far West Texas through applied research, education, and technical expertise to ensure a resilient water future for people, land, and wildlife. This is accomplished through applied research, focus on groundwater resources, education and workforce development, in other words, enabling water professionals for the future, and as well as technical assistance and community support. In this session, Meadows Research Institute scientists and collaborators and Saul Ross briefly, lightning round, about 4.5 minutes each, briefly describe the current, ongoing, and nascent research in groundwater, surface water, and spring flow, as well as incentive to plant and animal life using these water resources. Wish you luck, you're going to be moving fast. Yeah. On the first is Dr. Kevin Romantic, you're already familiar with. He's a senior research scientist at the Meadows Research Institute for West Texas Water. And he's going to be talking about groundwater, surface water interactions with the lower canyons of the Rio Grande, Wapsie River.
Okay, well thank you. I've got to move fast here. I'm talking about groundwater contributions to the Rio Grande and the lower canyons. So here's a map that's going to set this up for us. There's a Big Bend region. A couple of things on this map that I want you to know about locations. The Rio Grande Wildland Scenic starts down at the bottom of Big Bend National Park and extends out there to the Terrell Valley County line outside of the park. Federally designated Wildland Scenic. And then two of the gauges, USGS and IDWC both monitor parts of the river in this area. The two of them I want you to be aware of are Johnson Ranch in the National Park and Foster Weir industry. So what we do is, or what we know to say first, is that there's been declines in the river. The map on the right shows the blue, which is the model natural flow of the river system out of Colorado and the Rio Conchos out of Mexico to the Gulf of Mexico. And the red is the natural flows that we're currently measured for. So you can see those two stars, or those two gauges, Johnson Ranch and Foster Ranch. In those maps like that, usually this area that I've got the magnifying glass on is kind of blurry. You don't see much detail there. So what I'm going to show you is a little magnifying glass on that part between Johnson Ranch and Foster Ranch. On the left is a map of a recent game law study that we've done. We've done this many times. This is just the most recent one, just to avoid confusion. I just want to show you what a game law study is. You go out and you measure flow in the river in as many places as you can over as short a period of time as possible. And with some assumptions, there are no tributaries, you can associate declines or increases as either losing to the groundwater or gaining from the groundwater. So here's an example of what you might encounter if you go on a trip with me. To go through the Lower Canyon, it's about a week. It is truly wild and scenic, and you're going to see something like this almost every day. You're going to be challenged, and that's the easy part of this, Upper Madison Rapid. So field access is pretty tough, but it's fun. So here's a map that shows on the upper right what we do. We put the full boats in the river and measure flow. And then on the left, I've got that inset map, and then it's tied to the actual data, the flow increases or decreases that we've measured. On that upper left graph, you can see the green squares, Johnson Ranch, the green symbol on the right is Foster Ranch. In between, we've got many, many measurements that show not only the increase, but exactly where those increases are. Particularly from that point, which is river mile 750, down to San Rosendo, if you can see those labels right in the middle where the curve goes up. Pretty drastic. Can't do it for time. This is a groundwater dependent ecosystem. It supports an endangered species, which is the Texas hornshell, and another species that's targeted for listing, the Salina mucket. The groundwater dependent ecosystem is there because of that freshwater inflow. Otherwise, those species would not be able to exist there because of low flow, sediment buildup, poor water quality. All of that is fixed thanks to the groundwater inflow. So my summary take-home points for you are that the groundwater flow into the Rio Grande adds 180,000 acre-feet per year. We heard about the 1944 treaty yesterday and maybe a little bit today, and that stipulates Mexico's required deliveries of an average of 350,000 acre-feet. So this groundwater, when Mexico is not delivering, which during the current 5-year cycle system they don't have to, a lot of times this is the only water that's reaching on the reservoir. It also supports the habitat for endangered species, and it's just a cool place to go. This is my chance to show you a picture of up at Madison Rapids, and my chance to say, if you know, you know. Because I know some people in this room who've been there, and you know. And I'd really like to help some of the rest of you maybe join me on one of these science trips. Thank you.
Up next, we have Dr. Lucy Kelly. She's a research scientist at the Meadows Research Institute of West Texas Water, and she's talking about analysis of regional local rock fabric influences on groundwater flow toward lower Canyon and Solomon Springs.
Hi, I'm generally a slow talker, so you might have less information in here. I'll do my best. I am a structural geologist, which means I'm really interested in the way that rocks break and deform and crack. And going big from that, that means I'm interested in plate tectonics and earth history. And going local from that, that means that I'm interested in how those cracks and faults and spaces in rock hold water and allow water to move. So this rock fabric term is referring to the orientation of those cracks. You might understand, you might have known that porosity, or what holds water underground, you can first pass tend to think of it as like the space between sand and gravel grains, and that is true in many aquifers of Texas. But around here we have a lot of rock that is not just piles of sand and gravel, and so our groundwater is reliant on those interconnected fractures. They have the capacity to move water and to store water. And so this theoretical chunk of rock floating in space that's not tied to anything is very well understood to be the patterns that get broken under plate tectonic stresses and other stresses also. So that picture on the left is this theoretical chunk of rock, and the red arrows are, I get to bring up this term again, the anisotropic application of stress. So that just means uneven. Kevin brought that up earlier and was chided a little bit for it. So whenever you have plate tectonics active, which we do almost all over, and we are at a plate boundary here, it just hasn't really been fully born yet, you're breaking rock in somewhat predictable ways. So this picture on the right is some igneous rock that is broken in one of those predictable ways. This is a little bit more apparent, showing that kind of X pattern with 60 degrees and 120 degrees between each of those fractures. However, we're blessed with so much igneous rock. 30-ish million years ago, there was lava and magma everywhere, and that adds its own complexity of fracturing in how it cools. So this is a photo from a famous lava flow deposit in the Grand Canyon. I just want to add that this complexity goes on to these more rhombohedral fractures that we tend to see. So what we plan to do in this new research with the Meadows Research Institute is to use large-scale mapping along with outcrop data of fractures, looking at their orientations, their intensity, their lengths, whether they're full of mineral or not, so whether it's a calcite-filled vein or just an empty one, and how wide they are. And all of this information can be collected just, with your eyes on an outcrop, but we're also using digital outcrop models. This is one from one of my graduate students. This is, you can see the scale there on the left, and we can train the computer to do that same kind of measurement for us. So what we'll do with this data is use that orientation, all those things about fracture trace length and distribution and aperture, and make a model on the right there called a dense fracture network that then gets put into our more standard groundwater flow models that are already being used, with the intended outcome being increased accuracy of those flow models. And in particular, I'd like to do this with the aquifers that are moving toward San Solomon Springs region, as well as the lower canyons, and this area in the bottom, which is the as yet undefined Santa Elena aquifer. And hopefully this will help us with the desired future conditions for that.
Next, we got Dr. Kelly Lane, research scientist at the Meadows Research Institute for West Texas Water. She will be talking about investigating aquatic communities and ecosystem change in the Trans-Pecos region. She's an ecologist.
All right, it'll be a Christmas miracle if I get through these slides in 4 minutes, but I'm here to kind of give you a heads up on what the whole point of my talk is about, which is it's all connected. It's all connected, right? So we've heard a lot of great talks today about groundwater, and now we're going to hear some about surface water and what that means for the biology or the living components of these systems. So I'm going to give you kind of two random facts that are both connected that'll kind of lead us through my slides here. One, about 20 years ago, I volunteered on a spring break trip my last year in college to come count fish in the desert. All right, and about 2 years ago, I drove here for the first conference and I quit my job on the way here and said, finally, people are talking about West Texas water, it's time for me to come back. So this is kind of my love story between me and the desert. So when we talk about desert waters, these show up in a lot of different ways across the Trans-Pecos. So it can emerge from the groundwater as springs, rivers, wetlands, or as we like to call them, ciénagas, which you can see over in Balmoral. And these each support really unique aquatic communities. And I really want to point out the connection between us and the people who live out here and some of the surface waters that we interact with, like Balmoral. People travel 3 hours very frequently from El Paso to swim in this pool. So it's not just about the animals, it's about the cultural significance that we're connected to. So it's also preserving that and our way of life out here. So here's kind of some pictures of basically what I do in the field to try to get at what the health of these systems look like. And sometimes it's ultimately reflects what the groundwater may or may not be doing. So it is also a detection tool from the groundwater perspective as well. So in desert landscapes, it doesn't just support life, it reveals the condition of an entire system, right? So here's, more colloquially, I call myself a fish squeezer or a West Texas fish counter. And so this is kind of what you would do in the day of the field. I also count a lot of bugs. But this ecological perspective guides both my past work and then how I'm hoping to approach my new work through this new center. So I think it's very timely for me. I'm very excited. I'm bringing what I've learned from desert waters. And here's just kind of some of the focal points that I like to look at in terms of ecosystem change. So we can talk about water quality. We We can talk about it in terms of water quantity, and we can also talk about species interactions, mostly showing up in ways like invasive species and how they're affecting the system. So those are kind of the three areas that I focus on in my research. And so just examples of some of these are water becoming more salty, salinization, groundwater withdrawal, which is reducing the flows, the surface flows for species that need it, and then invasive species. And these are all species are responding to all of these stressors at once. So I'm really interested in that interplay between how do we overcome that and impose actual management and mitigation efforts whenever you're looking at various components of change. So if we have altered flow regimes, they can affect habitat availability, water quality can change the survival and reproduction of a species, and invasive species are often outcompeting our native species, especially in regions like the Pecos River, where it's not only becoming saltier, we're taking more water out, and we have a community that looks very similar to the Gulf of Mexico right now that's in there. So it's being replaced over time with species that are not native. So those are the kind of questions that I'm the most curious about. And to close, I want to emphasize that any one discipline and any one part of these stakeholders that are here does not make the biggest science gains for West Texas water, but by connecting them. So I wanted to end with connection. Groundwater sets the conditions, the surface water expresses them, and aquatic communities reveal the outcomes in ways that matter for us that can be ecologically and practically. So this is my one chair I cried because I made it with AI, but it's how we were all connected. Groundwater, surface water, aquatic life, and we hope to bring you real applied solutions. So thank you for the banter from the conference. I look forward to working with you all, serving my community, and I'm really grateful to the Meadows Foundation for securing this position in this spot.
Dr. Chris Mincy, many of you know him. He's a professor of biology at Stillwater State University, talking about give us an update on 3 salt-seater biocontrol opportunities along the Rio Grande and Pecos rivers.
Thank you all very much for coming and listening to this last talk of the speed lightning round, which is not specifically about water, but it's actually about insects that will be helping us to hopefully present and have more available water because of their activity. Now, the project that I've been involved with now for 20 years has been working with dealing with salt cedar control. Now, as we know, salt cedar tends to come into our western waterways, choke out other vegetation, reduce the amount of other organisms present. We have lower bird diversity, mammal diversity, and insect diversity, and it's overall a problem. Well, ironically, we didn't have salt cedar here until 1823 when we introduced it to stabilize creeks and make sure we didn't have erosion problems. Well, we don't have those problems right now with that, but we do have salt cedar becoming a monoculture, choking things out. We even have a picture here of the Pecos River itself, taken back in 1971, showing how dense salt cedar populations were. Well, the way to get rid of salt cedar, ideally, is to not have to go up there with our hands and rip everything out of the ground, but to get the other organisms to take care of things and help us to restore a normal, natural, balanced ecosystem. Toward this end, we went and worked with the USDA, and they located various different beetle populations that were found in Europe where salt cedar naturally comes from, collected them from Europe, brought them to the lab, made sure that they would be safe and viable to be able to release here in the United States, and then we did a release of them at various different sites along in Colorado, New Mexico, and Texas. The first site in Texas was in Big Spring back in the late 90s, and then in 2006, 2007 is when we started along the Rio Grande. We started with the Mediterranean beetle and the subtropical beetle, and these are the 2 beetles we're going to be focusing on, illustrating their different life stages of eggs, larvae, pupa, and then finally the adult stages. Now, with this project, we initially started up in about 2007. It didn't really take off very well. We had some problems and hang-ups. We went back again and kind of rethought things, restarted the project in 2009 around Alameda Creek along the Rio Grande. And then in 2010, the magical conditions seemed to work well. Temperature, precipitation, everything lined up well. The beetles took off, did well, and they went from being located within about a hectare worth of area to covering river miles. And we would go out and monitor their presence on branches, start seeing them basically dripping larvae because of how numerous they were. They'd start defoliating a single plant, and then over time they would defoliate an entire area. This is the goal of this project. This went on for a number of years. We've seen the population ebb and flow over time. Over the last 3 years, we've been continuing to spot check and look at them, and this map of the western United States shows dots indicating all the different places where these beetles have managed to get themselves established and to be moving about, helping to control salt cedar. The goal of the project is not to eradicate salt cedar. It's here, we're not getting rid of it. But what we can do is try to reduce its amount to let other things come in and establish a better, more normal ecosystem. Now there's other biocontrols out there. We also have a tamaric scale that can eat and inhibit salt cedar a bit as well. It knocks salt cedar down to about 30% as opposed to beetles that can sometimes completely defoliate and kill trees. And we also have the splendid tamaric weevil, as shown here, that's a beautiful coloration that showed up around 2015 here in Texas from other sites, and we've been monitoring and tracking them as well. What we're currently working on right now is I'm working on continuing to monitor activity along the Rio Grande, as well as beginning to try to reestablish this beetle's presence along the Pecos River. Toward this end, I've been monitoring and checking. We've had scales and weevils along the Pecos River, and beetles heavily found along the Rio Grande. This past summer, we went and collected beetles using beet bucket techniques and helped to redistribute and reestablish them along the Pecos. This upcoming year, we're hoping to see them continue to finish and get reestablished again. That work currently is being funded by Friends of the Pecos, but I'd also like to thank all my previous funders over the years as well. Thank you very much.